Work is a product of force into displacement into angle between them, angle between force and displacement. That means, like in this case, if this is an object, this object has to be pushed here and it
Okay.
experiences a pull in this direction. And this angle is theta. Now, if I draw a triangle here, this is theta, this is F, and suppose I label it as OAB. Now, cos of theta is OA upon OB. So, cos of theta will be OA upon F because OB is F. So, OA is F cos theta. So, here what happens is the part of the force which is in the direction of displacement is F cos theta. And
Okay.
when I say work as a product of force into displacement, I write F cos theta into S. So that makes work as F S cos theta. So we saw definition of work, the mathematical form, which is this, the SI unit, which is joule, the CGS unit, that is earth, and this is a derivation of relation between joule and earth. When the angle is 0 degree, the angle between the force and displacement is 0 degree. That means force and displacement are in same direction. Theta equal to 0 degree. That means force and displacement are in same direction. So what we get is cos of 0 degree, that is 1, and therefore work done is F into S into 1. So W is equal to Fs. So that is the maximum work done. An example can be of pushing a cart. So if a cart is like this, and if a person is pushing it, so he is applying a force, and the displacement of the cart is also in the same direction. So this is when theta is 0, that means the angle between force and displacement is 0, work done is maximum. The second thing over here, as you can see, when theta is equal to 90 degree, that means force and displacement are perpendicular. And in that case, you have cos of 90 degree is 0. So W is equal to F into S into 0. Work done is 0. If a person is carrying a load on his head and he is walking, so since the force required to balance the load is upward and the displacement is horizontal, so we have theta as 90 degree and the work done is 0. The same thing happens if a person or like a waiter is carrying a tray in his hand. He applies the force to balance the tray upward while he moves sideways. So angle is 0 degree, work done is 0. Theta is 180 degree, and in 180 degree you have force and displacement in opposite direction. Cos of 180 is -1. So we get W is equal to F into S into -1. W is equal to minus Fs. So we say that negative work done. Okay, an example is force of friction. A ball is rolling straight, so this is the displacement, but the force of friction is in the opposite direction. So therefore, the angle between them is 180 degree. Another example would be when a ball is thrown up. Okay, the work done by gravity will be negative. So this is ground, and this is a ball going up. So displacement is upward, but we know that gravity is downward. So that angle is 180 degree. So work done by gravity when a ball is thrown upwards. This is ground, and an object is pulled down with a force mg. Now, if you are pushing the object to a height h, so work equal to the force into displacement. Force is equal to mg, and the displacement is h. So when I have work done by gravity, I write W is equal to mgh. So basically, I have W is equal to Fs cos theta and W is equal to mgh as my two formulas. This is how we calculate work done by gravity. Okay, please write this down.
So what is mg?
Mg is the force. Any object is pulled down by the earth with a force, and that force is equal to the weight of that body, which is equal to mg.
Okay, thank you, sir.
So it is nothing but the. Okay, so W is equal to 0, it is 0. Example would be, okay, that means there is a wall, and if you are trying to push the wall doesn't go anywhere. You apply force. Okay, displacement is 0, so work done is 0. The second thing, if an object is performing circular motion, the object comes back to the original position after one revolution. So the displacement is 0, so the work done is 0. But the next thing is, when theta is equal to 90 degree, then also work done is 0. If you are running on a circular track and you complete half revolution, will your work done be 0?
No. No.
No, because your displacement will be equal to the diameter. So definition of power. It is one of the smallest definition.
Rate.
Rate of doing work is power. Okay, how fast somebody can do something. So I'll just give you an example. Suppose there are two boxes, identical box, okay, same type. Two people are there, A and B, and they have to push the box across this line. Now you know that the displacement is same, the weight of the box is same, and therefore the work done, which is force into displacement, will be same for both. But say for example, A does the task in 10 seconds and B takes 15 seconds. We say that A has more power than B because the rate of doing work, how fast one does the work, is more for A than for B. So that is the meaning of this statement, rate of doing work. So power is defined as rate of doing work. If there are two cars, one is a high-end car, which we say that develops more power. That means it can reach a particular place faster compared to the other car. SI unit of power is watt. Okay, now this is also a name of a person, James Watt, and this is a mathematical form of power. So power is work upon time. For 1 watt is 1 joule upon 1 second. So if you want to define a watt, we say that if 1 joule of work is done in 1 second, then the power dissipated is 1 watt. Okay, the power spent or the power dissipated by the body is 1 watt. That is how you define a watt. CGS unit. Now we know that if you don't measure it in joule, you will measure it in erg, and second will be second. So it is erg per second. There is no alternative to watt for a CGS thing. Okay. Then there are other units. The other units for power will be kilowatt. Now this is written as kilowatt like this, which is 10 to the power 3 watt. Then there is megawatt. Okay, you should be writing all of this. 10 to the power 6 watt. Then you have gigawatt. This is capital M, okay? This is capital G, 10 to the power 9 watt. Then there is milliwatt. This is -3. Then you have microwatt, 10 to the power -6 watt. Horsepower, that is 746 watt. You have to differentiate between power and work. What will you write?
Definition.
Okay. So the first point will be definition. Joule, watt. Work does not depend on time, but power depends on time. So this is displacement and this is force. What is this graph indicating? There is a constant force. Okay. Now, what is this shaded thing representing? Area. What shape is that?
Rectangle.
Rectangle. And the area is length into breadth. That is force into displacement, which is work. So for a force and displacement graph, the shaded part give you what? It give you the work done. Okay. Here we had a constant force. This is a variable force. The shaded part gives you the area, and that area is equal to the work done. Okay, please make a note of this. Now we have energy. Again, this chapter is easy for you because it gives you very small definitions. So definition of energy is capacity to do work. Okay, so it's like that energizer battery ad where certain batteries die early and one battery keeps going. So suppose you have a these boxes are kept here and there are more boxes on this side and there is two people, they have to carry these boxes to the other side and they have to stop them like this. So say for example, A gets tired after putting 20 boxes and B does 40 box. So we say that the energy of A is less than energy of B. So the capacity to do work is what is defined as energy. Now energy has the same unit as work, so therefore joule is the unit and the CGS unit will also remain the same as erg.